Good morning, students, and welcome to the Q&I summer course. So today, students, you will have your first maths class, and we'll start with the first chapter, that is rational numbers. Okay, so let's start the class, student. So first of all, let us understand what are the prerequisites this chapter. Okay, so before starting this chapter, you should know something about natural numbers. You should know what natural numbers are. You should know what whole numbers are. You should know what integers are, right? So these things you have already covered in the previous grades, basically natural numbers, whole numbers, and integers. So we'll revise those things as well when we talk about the number system, and then we start the rational numbers. So today's session would include, number system. So we'll discuss the basic number system which is there, right from natural numbers, whole numbers, integers, and rational numbers. All of this we are going to do. And then we'll start the properties of rational numbers. Okay. So your, syllabus starts with properties of rational numbers. So number system, knowing about number system is important because all these properties which we discuss for rational numbers would also means you would have studied all of those concepts in your earlier class as well. So let's start the session, student. So first of all, we'll start with number system. So you would have seen this diagram many a times, right? So let us begin with a basic concept. So we all know that the smallest number system which we come across is the subset of all number system is natural numbers, right? What are natural numbers?
So numbers from 1 to infinity.
Yeah. So all counting numbers starting from 1. So if we start counting the numbers from 1, so 1, 2, 3, 4 up to infinity. So these are natural numbers. Okay. Now a subset, a superset of this, right? So natural number is a subset of whole numbers, and whole number is a bigger set, right? Which comprises natural numbers. What are whole numbers?
So numbers starting from 0 to infinity on the positive side.
Yes. So counting numbers starting from 0 will give you whole numbers. So 0, 1, 2, 3 up to infinity, all positive numbers along with 0 is called whole numbers. So at times we also say that all natural number along with 0 are whole numbers. Okay. Now, please kindly mute yourself. Yeah. So a set which is bigger than this, bigger than whole numbers, are integers. What are integers?
So numbers including negative numbers, 0 and positive numbers.
Yeah. So all whole numbers, so negative whole numbers, positive whole numbers, and 0, right? So it's not fractions. No fractions would be included here, but whole numbers which are negative, positive, and 0, right? So 0 is anyways a part of whole number, are called integers. So positive and negative numbers together, whole numbers together, will comprise integers. Okay. And then a set bigger than that is rational numbers. What are rational numbers?
So like fractions and numbers between the whole numbers. Or the number
P
itself.
upon Q and are in positive and negative numbers.
Yeah, so all numbers which can be represented in the form P by Q, where P and Q can be integer. So it can be positive as well as negative. So ratio of integers where the denominator is not equal to 0 are called rational numbers. So all numbers which can be represented in the form P by Q, where Q is not equal to 0 and P and Q are integers, are called rational numbers. Okay. So these are the basic number system which we have already done, right? So do you also know what irrational numbers are? Any guesses?
Yes,
What
sir.
are?
Yes, sir.
The
Yes, sir.
numbers are in
Sir,
P
the Sir, the numbers which do not have a definite form.
0. It can be positive or negative numbers.
So basically, irrational numbers are those which cannot be represented in the form P by Q. So those numbers which cannot be represented as ratios of integers are called irrational numbers. Okay. So examples are square root, means root of all prime numbers are irrational numbers, right? Similarly, pi is an example of irrational number. And again, all decimal expansions which are non-terminating and non-repeating, these are again irrational numbers. So we'll come to all of that in the session today. So let's go ahead with the session. So this is the basic of the number system which we have discussed, students, just now. So now let's go one by one, recapitulate the definitions which we have given and the examples. So natural numbers, as I said, these are all counting numbers. So all counting numbers are called rational numbers. So it starts from, the counting number starts from 1 here. So 1, 2, 3, 4 up to infinity. These are all rational numbers. These are all natural numbers. Okay. So, and how do you denote a natural number? Is by n, right? So by the capital letter N. So this set of natural numbers is represented by capital letter N. And these are all counting numbers starting from 1 to infinity. Okay. So this is about natural numbers. Now, second set which we saw, the set which is bigger than natural numbers, these are whole numbers. So what are whole numbers? So all counting numbers starting from 0 are called whole numbers. All counting numbers starting from 0. So for example, 0, 1, 2, 3, 4 up to infinity. So when the counting starts from 0, all these numbers are called whole numbers. 0, 1, 2, 3, 4 up to infinity. And we denote a whole number by a capital W. So whole number is represented by capital W. Again, natural number was capital N, whole number is capital W. Now, all positive and negative whole numbers, including 0, are called integers. So this is a set which is bigger than whole numbers, right? So all positive and negative whole numbers, including 0, are called integers. Example, we start with negative infinity. We come to -3, -2, -1, 0, and then we go to positive numbers, +1, +2, +3, and so on up to infinity. So negative infinity to positive infinity, all counting numbers are integers. Now, it is denoted by capital Z or I. Okay. So I, we understand. So generally I is not used. It is mostly Z, which you will see in most of the books, that it is used as a symbol, as notation for integers, right? I is the initial of integer, we understand. Why do we use capital Z? Can someone tell me? Why do we use capital Z to denote integers? Anyone?
Sir, is it because we also have negative numbers?
No, but then why is capital Z? It can be capital A, B, C, anything. Why capital Z? It has a significance. The significance is Z, capital Z comes from a German word, Zahlen. So Zahlen in English means to count. And that's why capital Z is used as, initial, denoting, it is used to denote the integers. Okay. So this is a fact which you should know, right? Because, someone may ask you, you are studying integers. What does capital Z signify and why capital Z? Why do we not only use plus capital I? So capital I is not used much. What is being prevalent where, the whole world use capital Z. All mathematicians use capital Z to represent integers. That is because that capital Z is coming from the word Zahlen, which means to count, and here Zahlen has Z as its initial. Is it clear?
Yes, sir.
So this is one fact we studied today. Let's go ahead. Now rational numbers. So basic definition of rational number is a rational number is a number that is expressed as the ratio of two integers, right? Where the denominator should not be equal to 0. So these are two integers in numerator and denominator should not be equal to 0, right? So it is denoted by capital Q. Rational number is denoted by capital Q. So any number in the form, this is the mathematical definition, right? This is your mathematical definition. So what does definition says? Any number in the form P by Q, where P and Q are integers and Q is not equal to 0, is a rational number. So this is the definition which generally you will see across, in all the books. So you just need to remember that it is denoted by capital Q. Rational numbers are denoted by capital Q. Examples of rational number can be -2/3. So you can see here numerator is negative and denominator is positive. So, when I say that it is ratio of integers can be positive as well as negative. So that's what you are seeing in the first example, -2/3, and then 4/5, 3/-2. 12/5, -3/1, and 0. These are all rational numbers. So all whole numbers, integers, natural numbers, these are all rational numbers. For example, any whole number 5 can be written in the form 5/1. So it can be written in the form P by Q. That's why this whole number 5 is also a rational number. Similarly, 0 can also be said to be a rational number because 0 divided by anything is equal to 0 only. So 0 can be written as 0/1. So here this is P by Q, where P and Q are integers and Q is not equal to 0. Right?
Sir, I have one doubt.
Yes.
Sir, I have seen in many places that any number which is divided by 0 is either equal to undefined or infinity. So which one of them is it?
So see so both are same. So actually what happens is that if I write, for example, 2 divided by 0. So 2 divided by 0 is infinity or undefined, right? This is because infinity is not defined. Infinity for me can be, let's say, 1 crore. For someone else, it can be, 10 crores. For someone else, it can be 1 lakh. So infinity is not defined. The definition changes from person to person, right? For example, if you say how big it can be, it is very big. Now, very big does not have a definition, right? Very big for you can be some number. For me, it can be some other number. And for someone else, it can be some other number, because it's not defined. It's not actual number till which you can reach, right? So that's why, because infinity is something till which we cannot count. So that's why it is not defined. And that's why we write it either infinity or not defined. So these are same thing. Okay. Is it clear?
Okay, sir. Yes, sir.
But I have a doubt.
Someone else was asking something. Yeah, please go ahead.
Sir, can decimal be a real number?
Yeah, decimal can be a rational number. So when you represent rational numbers in decimal, there are two ways in which rational numbers can be represented as decimals. One is terminating decimal, and other is non-terminating and repeating decimals. I'll write it down for you. Okay. So there are two decimal form. So decimal form of rational numbers. Now this you are going to study in detail in class 9th. But yeah, you should have that foundation. Why foundation course is needed? Because so that you are able to understand what is there in store in class 9, 10th, 11th, and 12th, and your foundation, your base becomes strong, right? So that's why I'm telling you. So decimal form of rational number, first form is terminating decimal. Okay. So terminating decimal, for example, if I write, let's say 2 by 5. Now 2 by 5 is equal to 0.4. Now this is terminating because, there is nothing after 4. Means when you divide this, you will get 0.4 and you cannot further divide it because there is no remainder there, right? So this is called terminating decimal. So here you can see 0.4, any decimal, let's say we have 0.45, can be converted into P by Q form by dividing it by 100. 0.45 can be divided by 100. It will become 45 by 100. Now, if you cancel the common term, that is 5. So 5 9 times and 5 20 times. So this becomes 9 over 20, which is your P by Q form, which is a rational number. Okay. Now, other decimal representation is non-terminating and repeating. So non-terminating means it will not terminate, but the decimal will keep on repeating. For example, if I write 1 upon 3, 1 upon 3 is 0.3333 and so on, right? So it is neither terminating, but it is repeating. It is repeating. It keeps on repeating. And this can be also represented as 0.3 and there a bar over 3. Bar over 3 means 3 is repeated till infinity. Is it clear? So both these numbers can be represented in the form P by Q, and that's why these are rational numbers. So rational numbers, when they are written in decimal form, you can write it in these two forms, that is terminating decimal and non-terminating and repeating decimal. Okay?
Yes, sir.
Okay. So one of the student asked that, sir, you are our physics teacher. So I teach physics and maths both, right? So because our maths teacher was not well, so I thought of starting maths because, there has not been maths classes in last 2-3 days. So I thought that I'll, chip in here. Okay. Let's go ahead. Now, properties of rational numbers. So first property is closure property. What does closure property means? Can anyone tell me?
Yes, sir.
Yes.
Sir, on a rational number, either subtracted, added, or multiplied by another rational number would always result in a rational number.
Okay, so then we say that rational number is closed under addition, subtraction, or multiplication, right?
Yes, sir.
Yeah, so we'll go in detail of all of these properties. So first property of rational number which we are going to study in this chapter is closure property. Second is commutative property. Third is associative property. Fourth is distributive property. Fifth is additive and multiplicative identity. And sixth is additive and multiplicative inverse. So all of these terms you must have heard when you were doing, whole numbers and integers. Why? Because these properties we studied there as well. So property remains the same, but then we'll have to see whether it is valid for rational number or not. Okay. Let's go ahead, student. So first of all, we'll start with closure property. So closure property, what the property states is rational numbers are closed under addition. What does this mean? This means that for any two rational numbers A and B, the sum of these two rational numbers A plus B is also a rational number. Okay. So when you add two rational numbers, the result which you get is also a rational number. Then we say that this rational number follows the closure property, or rational number is closed under addition. Okay. So for example, when you add 3 by 8 and minus 5 by 7, the LCM you will take 8 and 7 LCM is 56. And then you cross multiply. So 3 into 7 becomes 21 and 8 into minus 5 becomes minus 40. So we have that common denominator 56, which is the LCM of 8 and 7. And then we convert 3 by 8 with denominator 56 by multiplying both numerator and denominator by 7. And similarly, minus 5 by 7, we multiply both numerator and denominator by 8. Is it clear? So then you will get 21 minus 40, that is minus 19 over 56. Now you can see both of these 3 by 8 and minus 5 by 7, these are rational numbers, and the sum of this is also a rational number. So that's why we say that rational number are closed under addition. Clear, students?
Yes, sir.
Okay. Now, second property, rational numbers are closed under subtraction as well. That is, for any two rational numbers A and B, A minus B is also a rational number. So when you subtract two rational numbers, the result again is a rational number. Okay. So for example, again, I'll take the same two rational numbers. 3 by 8 is a rational number and minus 5 by 7 is another rational number. When we subtract them, we get 61 over 56. So both these numbers are rational numbers. When you subtract them, you again get a rational number. Clear? Let's go to the third closure property, that is closure property in multiplication. So rational numbers are closed under multiplication. Again, what does this mean? This means that when you multiply two rational numbers, the result again is a rational number. So if we have two rational numbers A and B, when we multiply them, this again is a rational number. For example, minus 2 by 3 is a rational number. 4 by 5 is a rational number. The product of this is minus 8 by 15. This again is a rational number. Yeah, someone wanted to say something?
Sir, I was removed from the meeting by someone.
Okay. There may be some technical glitch, but yeah, no one is purposefully doing that. Yesterday also in one of the class this was happening. We have been checking there. It's not possible to remove someone, but yeah, we'll try and look at it again. Okay. Okay. So before I go any further, I'll tell you, students. So there is a form which has been circulated. Yesterday also there was a form which was circulated. Today also we are circulating it, and there will be calls which will be made to you for the proficiency diagnostic test. As I said, the importance of proficiency diagnostic test is that gives you an understanding of your strength, opportunities, hurdle and weakness areas, so that we can plan your classes for this summer course. And by the end of summer course, you are all your learning gaps are covered and you are well prepared for any exams which you take once the summer vacations comes to an end. Right? So please fill this form where you have to fill all the data, and also please answer to the call and give that email ID and mobile number which is handy with you, so that you can log in on the platform tomorrow to take that proficiency diagnostic test. It is very important, student. Please do that. Okay.
Sir?
Yes, student.
Will we have classes on Saturdays too?
No, you have classes from Monday to Thursday. Friday, you will have a weekly test, but this Friday, you have a proficiency diagnostic test. Saturday and Sunday, you need to, enjoy your summer vacation, do all the activities which are there, for which you have been waiting for that summer vacation, right? And then you can practice some questions which we do. Okay?
Okay, sir. Yeah.
Okay.
Thank you.
Okay, let's go ahead, students. So, rational number is not closed under division. Can someone explain me why?
Yes, sir.
Yes, please.
Because, sir, during division, it may be possible that they are cancelled out, or it may be also possible that the whether it is not a rational number.
Can you give me an example?
Just give me a second, sir.
So I'll tell you. Yes.
Natural number are not closed under division because the answer may be in decimal form also.
No, I told you that decimal can be rational numbers. So something else. I want to hear something else. I'll give you one example.
Sir, it will be an integer.
Yeah, but integers are rational numbers. So for example, if I write -3, I can write it as -3/1, which is a rational number. All integers are rational numbers. I'll tell you. Now, if we write 2 divided by 0, now 2 is an integer, 0 is also an integer. But 2 by 0 is not a rational number. It is not defined, right?
Yes, sir.
So this cannot be a rational number. So even though the numerator and denominator are rational numbers, because 2 and 0 both are rational numbers, the division of 2 by 0 is not a rational number. So that's why we say that rational numbers are not closed under division. So for any rational number a, if I do a divided by 0, it is not defined, and that's why we say that this is not a rational number. In some cases, it will be a rational number. For example, -5/3 divided by 2/5 gives you -25/6. In all other cases, it will be rational number, but only when it is divided by 0, it will not be a rational number. So because there is an exception, we cannot certainly say that whenever you divide two rational number, you will get a rational number. So when you are not certain, that means it is not a property. So that's why we say that rational numbers are not closed under division. Clear, students?
Yes, sir.
Good.
Yes, sir.
Let's go ahead. So here, this is a rational number, but -5/3 divided by 0 is not defined. That's why it is not a rational number. Okay. Are you all also noting it down in your notebook? Do you write notes? Do you make your notes for the class?
Yes, sir.
Please do that. Okay.
Yes,
Let's
sir.
go ahead. Good. Now, this is an, we'll just revisit on closure property. For all these, numbers, for example, for natural numbers, whole numbers, integers, and rational numbers, we say that, rational numbers are closed under addition. Yeah, because, when you add two rational numbers, you will always get a rational number. Is it closed for integers also? When you add two integers, do you always get integers?
Yes, sir.
Yes. So integers are closed under addition. So this is also yes. Whole numbers. When you add two whole numbers, do you always get a whole number?
Sure. Yes, sir.
Yes.
Yes,
so this
sir.
is also true. Good. If you add two natural numbers, are they always a natural number? Is it always a
sir.
natural number? Yes.
Yes.
Now let's see subtraction. So when you subtract two rational numbers, you will always get a rational number. We just saw. When you subtract two integers, you will always get an integer. For example, if I subtract -3 minus of -5, so this is -3 plus 5, that is +2. So this is an integer, right? When you subtract two integers, you will get an integer. What happens when you subtract two whole numbers? Will you always get an whole number?
Oh, sir.
No.
Give me an example.
5 minus 7.
Yes, if I do 5 minus 7, we will get -2, which is not a whole number. Okay. So that's why we say that whole number is not closed under subtraction. And similarly for natural numbers also, it is not closed for subtraction. If you subtract two natural number, for example, 5 minus 7 is -2, which is a negative number. It is not a natural number. It is an integer, right? So that's why it is not closed for natural numbers are not closed under subtraction. Now let's come to multiplication. When you multiply two rational numbers, what happens?
We
You
get
will
a
always
rational
get a
number.
rational number. So this is yes, it is closed under multiplication. Are integers closed under multiplication? When you multiply two integers, do you get an integer?
Sir.
Yes, very good.
Yes, sir.
Similarly, when you multiply two whole numbers, you will get a whole number. And when you multiply two natural number, again you will get a natural number. Now let's come to division. So when you divide two rational number, you may not get a rational number as we saw. So this is not closed under division. Integers, when you divide two integers, you may get a fraction, right? Which is not an integer. That's why it is not closed for division. For whole numbers, when you divide two whole numbers, you may get a fraction again. So it is not closed under division. And natural numbers also, when you divide two natural numbers, you may not get a natural number.
Yes, sir.
Right?
Yes, sir.
So all of this is clear?
Yes, sir.
Yes, sir.
Okay.
Sir, I have
Let's-
one doubt.
Yes. Yes, Ishan. Please ask.
Sir, how can we prove the natural numbers when it?
I lost you in between. So can you please repeat your question once?
Sir, somebody is muting me all the time.
Okay. Okay. Please tell once more.
Sir, can you prove natural numbers division, sir?
Yeah, I'll do that. So let's say we have two natural numbers, 2 and 3. So 2 divided by 3, this is not a natural number. So even though 2 and 3 are natural numbers, 2 by 3 is not a natural number. Okay.
समझने के लिए
Get it, sir.
Vidhi, please can you mute yourself?
ठीक है, समझो जितना गेन कर सकती हो कर लो.
Okay. So now another example, we can take. For example, we have 10. So let's say we have 10 over 5. So these are natural numbers and 10 over 5 is 2. This also is a natural number. So there may be.
Sir, you're on mute. Sir, you're on mute.
Sorry, you are on mute.
Now, is it fine now?
Yes, sir.
Yes,
So
sir.
there may be
Yes, sir.
certain cases where you divide two natural numbers, 10 over 5. This is equal to 2. Now this is a natural number. Clear? Okay.
Yes, sir.
Let's go ahead. So now come another property, commutative property. What are commutative property? Commutative property means that when you, for example, when you add A plus B, this is equal to B plus A, then we say that it follows commutative property. So now again we'll check that whether rational numbers is commutative over addition, over subtraction, over multiplication and division. So we'll check one by one. So addition is commutative for rational numbers. This means that if we have two rational number A and B, A plus B will be equal to B plus A. So order in addition does not matter. You can add 2 by 3 plus 3 by 2 or 3 by 2 plus 2 by 3. You will get the same result. So that's why we say that addition is commutative for rational numbers. Clear, students?
Yes, sir.
So let's say we have these two rational numbers 3 by 8 and minus 5 by 7. If we add them and if we change the order, if we flip the order, minus 5 by 7 plus 3 by 8, what are you going to get is, minus of 19 by 56. So whatever the order of addition, you add 3 by 8 to minus 5 by 7 or minus 5 by 7 to 3 by 8, the result is going to be same, that is minus 19 by 56.
Sir, you have
Sir, you are
muted
on
it.
mute again. Mute.
Okay.
कर देता हूँ.
So there is some technical glitch which is happening. Okay. So yeah. So 3 by 8 added to minus 5 by 7 and minus 5 by 7 added to 3 by 8 will give you the same result. Okay. Now subtraction, is it commutative? Subtraction? It is not commutative.
No, sir.
Sir.
Yeah, it is not commutative because, for normally also if you check for integers, for integers, natural numbers also you will say that, see 2 minus 3 will be minus 1, but 3 minus 2 will give you plus 1. So for any number you will see that subtraction is not commutative. So subtraction is not commutative for rational numbers. That is, for any two rational numbers a and b, a minus b will not be equal to b minus a. For example, if we take these two rational numbers, that is 3 by 8 and minus 5 by 7, the difference 3 by 8 minus of minus 5 by 7 is 61 by 56, but minus 5 by 7 minus 3 by 8 will be minus 61 by 56, which are different. Is it clear?
Yes, sir.
Now multiplication is commutative for rational numbers because when you multiply a into b, it will be equal to b into a for any two rational numbers a and b. If you take one example, minus 7 by 3 o into 6 by 5, this is minus 42 by 15. You multiply the numerators, minus 7 into 6, you will get minus 42. Similarly, 3 into 5 will give you 15. And if you multiply 6 by 5 to minus 7 by 3, this again is equal to minus 42 by 15. Right?
Sir,
So,
I have a doubt.
Yes, please. Please ask.
Sir, can we it is important that we can reciprocal in division only, not in multiplication.
Yeah, so in multiplication, what happens that if you have two numbers a by b into c by d, so when you multiply this, you will multiply the numerators together and denominators together. So this is a into c divided by b into d. But in division, when you divide a by b with another rational number c by d, then you convert this division into multiplication by taking a reciprocal of the second number, that is a by b into d by c. This becomes ad over bc. Is it clear? So in division, can you come again?
Why it is necessary?
Because these are two different things. For example, you have a number 2 by 3, you are dividing it by 4 by 5, right? So here what happens is, because you are dividing it, you will write it as 2 by 3 over 4 by 5, right? So when you solve this, this becomes equal to, this 5 will go and multiply with 2. This will become 10 over 12, right? So this process, when you simplify it in terms of multiplication, this becomes 5 by 4. So for example, if I say a divided by b, so this is same as a over b, or this can also be written as a into 1 by b. So when you have converted division into multiplication, what you have done, you have taken a reciprocal and multiplied it. So this same concept is valid for rational numbers as well. When you are dividing, you are multiplying it by the reciprocal of that. Is it clear now?
Yes, sir.
Okay. Now commutative property. So division is not commutative for rational numbers. That is, for any two rational number, we cannot say that A divided by B is equal to B divided by A. These will be two different numbers. For example, minus 7 by 8 when you divide it by minus 5 by 7 will give you minus 49 over 40. That is 49 by 40. You can cancel this negative sign. And when you do minus 5 by 7 divided by minus 7 by 8, this will be equal to minus 40 by minus 49. That is 40 over 49. That is reciprocal of each of these. So A divided by B and B divided by A, these are reciprocals. They are not equal. So that's why we say that division is not commutative for rational numbers. Is it clear?
Yes, sir.
Okay.
Yes, sir.
So what
Yes,
did
sir.
we do today, students? We covered the number system and then we started with rational numbers. We did closure property today and then we did commutative property. Now in next class when we meet, we'll do associative property, distributive property, additive and multiplicative identity, and additive and multiplicative inverse. Okay. So thank you, students. Thank you for joining in today. So we'll continue our chapter, that is rational numbers, in the next class when we meet next week. So tomorrow you will have a proficiency diagnostic test at the same time, 11:30. So be there for that test because it is very important to understand your strength, opportunities, hurdle, and weakness areas. Right? There is a Google form here where you need to fill in all the information. Okay, so that we can create your account, and then that account can be used to practice on the platform throughout the month, throughout the summer course, right? And there are so many interesting things on the platform. Okay, so please register yourself. Thank you. Thanks a lot. Thanks for joining in. Bye and take care.
Sir, I have a doubt.
Yeah, please.
Sir, the proficiency test that will happen tomorrow, like what will exactly happen? Like, will we have classes or something?
No, so you will be joining on the link as you are joining today. We will guide you how to start the test. Once you have started the test, you have to switch on your camera and then take the test. And once the test is over, you submit the test and then you can go. So tomorrow there will be only diagnostic test. No classes will be there.
So will this
yeah,
no classes? Is
you will
it
be
like no classes every Friday?
Yeah, every Friday you will have a test. This Friday you have a proficiency diagnostic test. From next Friday you will have a test of whatever we have covered till now.
Okay, sir.
Okay. Thank you. Bye and take care.
Also doubt.
Yes. Yeah.
So
yeah,
the
please.
link will be same as today's class.
Yeah.
for
Yeah.
tomorrow?
Links. Yeah. Yeah. We'll share the links with you also. It will be same.